A Monaco here. Lesson 7 in our acids and base unit, we're going to get to the neutralization reaction. So what happens when an acid and base react? You know this a little bit. You've taken baking soda, a base, and vinegar and acid and mix them. They fizz and pop and bubble and make a whole big mess. Well, what happens at the atomic level is the acid and the base are neutralizing. So we're going to go into that in more detail in this particular lesson. So neutralization. This is a great visual for what's going on. So NaOH, a base, and HCl, an acid, hit each other. Well, in the picture, I'll draw here a little bit. I'll illustrate what's going on. The hydrogen from the acid and the sodium from the base, they kind of swap. So this is like a double replacement reaction. So the hydrogen ends up with the hydroxide, and the sodium ends up with the chlorine. So we got sodium chloride and HOH. HOH, that's the same as H2O. So we get water. And NaCl, that's ionic. We call that a salt. So the two products of any neutralization reaction are water and salt. Water is neutral, and salts don't produce acidic or basic ions in solution. So there's nothing left over to make the solution acidic or basic. So it's called a neutralization because the pH comes into about 7 when we're all done. So this is another visual of how it's done. So the hydroxide OH, the red and white sphere, and the hydrogen, the white sphere from the HCl, come together to make H2O, leaving Na and Cl left over to form an ionic compound. Here's another visual of how it goes. An acid and a base bump into each other and swap. Double replacement. Hydrogen moves from one compound to the next, hops on with the hydroxide, makes water, and the metal and nonmetal ions make a salt. So we got common acids and common bases. Let's see. The hydrogen and hydroxide from the acid and base come together to make water, and the sodium and bromine, in this case from sodium hydroxide and hydrogen bromide, make our salt. Pretty simple. Now in this particular one, we still have the hydrogen and hydroxide coming together, but we can look at it like a plus minus, a different way of looking at the same thing. So the positive hydrogen is going to end up with the negative hydroxide to make, well, water. And the negative sulfate and positive potassium are going to come together to make a salt, potassium sulfate. Now in this case, you got to do a little balancing because sulfate is a -2 and potassium is a +1. So you got to squeeze a little 2 in there, K2SO4. All right, that's kind of how it works out. You got to balance these things proper. Back to the crisscross method and balancing of chemical equations. Okay, that's how you do it. Now, a triprotic acid, which means it's got 3 hydrogens, is going to react with a simple base. So we got 3 hydrogens, same kind of method. Positive to negative, H plus OH makes H2O, or HOH. And then the lithium and the phosphate make LiPO4. But the problem is you needed 3 hydrogens to cancel out your PO4. So you're going to need 3 lithiums to cancel out that PO4 now. And so we then triple the lithium hydroxide amount to see that we would actually make 3 waters as well. We had 3 hydrogens to give up, so we need 3 hydroxides to take them, which is why there's 3 as mole coefficient in front of LiOH and 3 in front of HOH, because you would make 3 water molecules. So here are some balanced neutralization reactions to do. Okay, so let's use that method where the H and the OH combine and the Br and the K combine. So HOH, that's our first thing, water. And Br and K. Well, K and Br combine together in a 1-to-1 ratio because K is a +1 and Br is a -1. So we have no balancing to do. Number 1, check, we're done. Next one, simple way of doing things. We're going to take the hydrogen from the acid and react it with the base, the hydroxide from the base. We're going to get HOH. And then we're going to look at Na and C2H3O2. Well, Na is a +1, and C2H3O2, that's acetate. That's a -1, so we don't have any silly balancing to do. We made water and sodium acetate. Our next one, we're going to do the same thing. We're going to take the hydrogen off the acid and and smash it into the hydroxide from the base. So we're going to make HOH, and we're going to take the metal potassium and put it in with a phosphate, KPO4. Now we have to check our balance. K is a +1 ion, and PO4 is a -3. So we need 2 more K plus 1. So we're going to say K3PO4. And that means that we had to triple the amount of K, which, as we can see, we had 3 hydrogens, and now we have 3 hydroxides. So we would make 3 waters at the end. The last one seems to be almost balanced for us. We got an H and an OH, so that'll make HOH, water. And then we got Ca and O3. So Ca and NO3. Now we got to check our subscripts. Calcium's a +2, and nitrate, NO3, is a -2. So, yep, we are good to go. The only thing we have to realize is that we had 2 H's from 2HNO3 and 2 OH's from the CaOH. So we're actually going to make 2 water molecules in that process. Neutralizations are just double replacements. You just remember every time you make one thing is water, HOH, or H2O, however you want to write it. And the other thing is the salt formed from the other ions left over. They have no other choice but to get together. And that brings it to an end of neutralization. Lots of those to practice in the packet. Double replacement reactions, look to make water, and balance your salts, subscripts. That is what I have to say to you about writing neutralization reactions. Thanks for watching. Talk to you next video when we're going to do titrations, calculations. Where's my button? I'm going to click it. I'll turn it off.